1. E to the 7x dx. Anybody want to give me an answer or volunteer on that? Alex, you want to go ahead for me?
E to the 7x over 7 plus c.
Now how did you do that? What pattern did you see?
Well, basically,
What was your thought process? Yep.
Well, my thought process was E has the same, E to whatever number has the same derivative every time, so basically take that derivative, put it on the bottom.
So e to the x, the antiderivative of e to the x is e to the x. Normally you would have to multiply by 7 if you're taking a derivative, but with the antiderivative, you just multiply by 1/7. You put it on the bottom like an antiderivative. We can do that because it's linear. Because it's linear, we can take this, do a quick u sub is what we're doing, and take the coefficient and flip it over and multiply. That is correct, 100%. All righty, everybody get number 1 for me? Okay, number 2. Who wants to try number 2? Anybody? Yeah, go Griffin.
1/7 e to the x to the 7th.
Now how'd you get, what did you do? What was your thought pattern? Tell me what you were looking for.
I saw that it's like a composition.
Ooh, thank you.
X to the 7th.
Uh-huh.
Its derivative was also there.
Uh-huh.
X to the 6th.
Nice.
So I did use so.
You let u be x to the 7th?
Yes.
You saw the derivative was also in the integral? Perfect. Oops. Did that wrong, Tina. Did that way too fast. Multiplied by 7, took the derivative. I'm not sure if you did it this way because there's other ways to do it, but this would be the way that I did it. And then you did 1/7 e to the u du gives you 1/7 e to the u plus c. You went backtracked, and this is what I heard you say. 1/7 e raised to the x to the 7th plus c. Perfect. Perfect. Any questions on number 2? Number 3. What makes this guy different? I know a lot of you guys know this. You're like, Tina, this is way too easy. Just give me the hard stuff, right? Yeah, Anna.
It's an integration by parts problem.
Why? What made it say integration by parts?
There's two functions and one's not the derivative.
Right, there's 2 functions here. Here there's 2 functions, but this is not the derivative of e to the x. There's no composition either in this one. Very nice. So, want to walk me through it? So what did you do?
I had u be 7x and dv as e to the x dx.
Uh-huh.
And then du was 7 dx. And then v was e to the x.
Beautiful. And then, what's our formula for integration by parts? We have a product. Let me just write down what you said quick so I have it in my notes here. It was a product. No composition involved, but it was the product, that pattern that gave it away, that we're going to use the tool integration by parts. And it's what? UV minus
uv minus
the integral of v du. Perfect. And so when you did that, you did UV, which was 7x e to the x, right? Minus the integral of
7 e to the x.
7 e to the x dx. And you just took that integral right away because we know the antiderivative e to the x is just e to the x. So did you get minus 7?
e to the x plus.
Perfect. Any questions, guys? How are you on those 3? You're like, okay, Tina, we're good to go. We got this. Do you see the difference between these? I put these on the final. I'm telling you, this is what's on first test, on the first final. You get a bunch of integrals, and you have to decide which tool to use for those integrals. Does that make sense? So you have to start getting used to saying, okay, what's going on? What tool, what pattern do I need to apply? Does that make sense to everybody? Patrick, is that a question or just my arms? Question? No? Oh, okay. You can do that again then. That's okay. I just wanted to make sure I got it if there was a question. Anybody else? Everybody's good? Sweet. Are you ready for some challenge ones today? Don't worry, we're going to hit trig. I read all your journals over the weekend, and some people said they wanted to do more e to the x's and exponential functions. I hope this is helping solidify those exponential functions for you guys. All right, so we are going to work today. Continuing in our notes, we're going to take a look at a couple more integrals with e. particularly in our notes, problem 6 and 7. Now, we'll start with 6, then we'll go to 7. What do we notice about these guys first of all, though? Just looking at them before I get bigger. I don't know if you can see this. It's itty bitty. This top one, 6, says x squared e to the 3x. X squared e to the 3x. 7, which is underneath it, is x cubed plus 4x squared minus 2x plus 3 e to the minus x. But what do you notice about these guys? It's a product, right? It's a composition, but the derivative of this guy does not equal this. Are you with me? So that means we need integration by parts. Go ahead, guys. Give me what this answer is going to be. Integration by parts on this one. I'm going to wander. That way you can ask me if you have any questions, okay? Any questions? X squared times e to the 3x. X squared times e to the 3x. UB minus little v du. So that means if you have a product, you want to find a u and you want to find a dv. So you have to figure out which piece you want to let u. Now look in your notes a second. Last time in our notes we talked about u's and we said there's one order that we can use if we want to process, because sometimes we like process. Did you write the word ilate down? Do you remember writing that? Can you write ilate at the top for me? I-L-A-T-E. I-L-A-T-E. Ilate. I means inverse trig. L means logarithm. A means algebraic. Algebraics are polynomials. Trigonometric and exponential. This is an order that you can use to pick u. Okay? So you see a product and you say, I am going to use integration by parts, which is a tool. I need to find u, and I'm going to go down this order. Do you have an inverse trig function in this problem? Like arc sine, arc tangent? No. Okay. Do you have an L, a logarithm? ln, natural log? No. Do you have an algebraic or polynomial? Yes, you do. So that is what you're going to let u be. See, this is my logic. So u equals, you write u equals x squared. Perfect. dv becomes everything else, Alex. E to the 7x dx, or 3x dx. So now you just give me v, which is the antiderivative, and you gave that to me, so I know you can do that. Good. Now you apply this formula. Write this down. uv minus the integral of v du. What are you guys noticing? Do you notice you actually have to do integration by parts twice on this? Do you guys see that? Are you guys seeing that? Oh yeah, oh yeah. Integration by parts twice, because you get another one, right? So you gotta do it twice. Once, and then again. Guys did it once, and then again. Nice. So now you're taking u and v and multiplying them. Integral of v du. Yeah, you see why you got integration by parts again. Do you guys see? Do you see the patterns? Do you see why that integral comes up again and you have to do the product rule again? I mean, well, the product rule, which is integration by parts. Do you see how you got another product again? So pick a different u this time. Good, you got me an answer at the end. And if you want to check to make sure you did it right, that smells like good, strong coffee. You can always take the derivative when you get the bottom and go backwards. Yes, sir. Let's see, so you 2x. You lost your x. You see? V du. I think you thought that was dx. So it's 2x dx. Put a dx at the back. Nice. Nice. Very nice, Joel. So now you got it. You see you got an x and an e. You product again, right? Do it again. Pick new u. Very nice. Very nice. So you got this. And you did u again. Did you pick a new u here? Ooh. I know why. What's the derivative of x squared? 2x. That's where that extra x is coming in. see what I'm saying? Any algebraic is any x in the thing. How are you? Good? Oh, no, keep going, keep going. Talk to Chris. Patrick, you got some work for me? Oh, nice. Plus C at the end? Uh-huh. Very nice. Let me bring up Quinn. You got an answer for me? Is it 3 terms at the back end when you're all done? Oh, it is. Let me see. Let's see if you guys are getting somebody. So we'll see what we're getting here. Let's see. So I would let you. Ooh, nope, not that way. Gonna make it a little smaller. Okay, so I would probably let u be x squared because of my ILATE rule. I picked my algebraic function before I do anything else. And dv I would let be e to the 3x dx. And v then is 1/3 e to the 3x. And when I put everything into my formula, uv minus the integral of v du, we get the following. We get x squared. Be nicer, Tina. Times 1/3 e to the 3x minus the integral of 1/3 e to the 3x times 2x dx. Now, I'm going to clean this up a little bit. I tend to I'm going to clean this up. I like to put my coefficients first. That just is something that I like to do. I also like to write my x's before my e to the x's, but it's completely up to you how you want to write them. Okay? But I do it for habit because our brains, believe it or not, are based on sight, on doing, and if you see a pattern with x's first, then if you rearrange it and put your x first, it pops out better for you. Got a product here, need to do u substitution again. Gonna let u this time be, let's change colors up. U this time. Now, 2/3 could bring out front, 2/3 could go with the e. You can separate it however you want to do it. I think I'm gonna keep my 2/3 just with the x, so that the derivative of 2/3 x is just 2/3. You might have done it different, and that's okay. What's important is when we get to the bottom, we got the same thing, okay? So you might have let u be something different. That's all right, okay, guys? But we got to have the same thing when we're all the way down at the bottom. So now we go uv minus v du again, leaving the first part as it was, 1/3 x squared e to the 3x minus. Make sure I put parentheses around this whole sucker because I'm doing the whole thing here. uv, so uv minus the integral of v du. See if you guys are getting the same thing when we come down here. Again, I like to put all of my coefficients together. So, did you get so far 1/3 x squared e to the 3x minus 2/9 x e to the 3x so far? And then that last bit, I'm going to highlight it. There's a minus, minus. So you better make sure you got a plus going on in there because WebWork will spit it at you and say wrong if you put a minus there, right? And then you've got the antiderivative. So I've got 1/3 times 2/3 times an extra 1/3 coming from the antiderivative. Let's see. Final answer, I'm getting to be 1/3 x squared e to the 3x. Stop me if I make a mistake or yell, Tina, you just goofed it up. Plus 2/27 e to the 3x plus, ooh, Tina, you just goofed it up. E to the 3x plus c. Do your coefficients match? Do your pluses and minuses match? Does everything look good? How many people got this? How many people did this? Oh yeah, oh yeah. Very nice, very nice, very nice. Whoever didn't get it, do you guys see what you might have done wrong, what you might have done right? Where you might have gone astray if you went astray. How are we? Patterns, right? Today we're all about patterns and critical thinking. How you doing? Any questions? Now, occasionally, if you're taking differential equations, you're going to be working with these a lot in the future. All my engineers, you're going to be seeing lots of integration by parts coming up. Not so sure about computer scientists where you guys use them, but grad school maybe. If you're taking GREs, I don't know. It's been a long time. All right, we're going to take one more problem here, though, on the last one. Any questions? Okay. Now, before we do anything, I want to look at this sucker. I've got an e to the x times an algebraic expression, right? So it's going to be integration by parts again, right? But last time we had an x squared and we had to do integration twice. Did you see that? Because x squared went down to x and then it went away. So this time we'd have to do integration by parts 3 times. Not only that, but we got a gobbledygook going on. I don't know about you, but that's a lot of minuses and things to keep track of. So there is another way to do integration by parts when you have to do multiple steps, and that's called the tableau method. Now, some of you guys might have learned that in Calc BC, if you ever took Calc BC. So I am going to show you a tableau method. It's really basically for only well, you can use it anytime actually, but it really comes in handy when you have complicated algebraic expressions with e, complicated algebraic expressions with sines and cosines. When you have algebraic mixed with sines and cosines, or e, that's where you get tableau method. So I'm just going to highlight, here we've got an algebraic expression, so I'll just write down algebraic. And next to it, we have what's called a transcendental. Transcendental are all the cool things like e's and logs and sines and cosines and tangents. Those are our transcendental functions. So when you have an e, or a sine, or a cosine, or a tangent, combined or multiplied by an algebraic expression in an integral, a product, often we use what's called the tableau method or a table method, okay? So we've got a table method for doing integration by parts. So we're going to create a table for integration by parts. It just helps keep track of things quicker instead of having to do it and do it again and do it again and do it again kind of thing, okay? So let me show you the table. All right, like I said, some of you guys might have seen this before. You're going to start with u, and you're going to start with a dv just like normal. So your first thing is you have to decide what you're going to let be u, what you're going to let be dv. And remember, u in the I-late stage tends to be algebraic before anything else. Well, not necessarily, not before logarithm, but I-late. So inverse trig, logarithmic, algebraic. So for our particular problem, u is going to be that algebraic thing. X cubed plus 4x squared minus 2x plus 3. Okay? What's that make dv? Go ahead, Tim. E to the negative x dx. Perfect. So dv becomes e to the negative x dx. All right, so now you got your table set up, and now normally you would do uv minus the integral of v du, and so you'd have to find du and antiderivative, and that's exactly what you're going to do in this table. You're going to start here with your u, and you're going to find the first derivative. So you're going to take derivatives. So you're going to start with u, and you're going to go down, and your next step is to take a derivative, okay? So what is the derivative of x cubed plus 4x squared minus 2x plus 3? Reed, you want to give me that derivative?
It would be 3x squared
plus
8x minus 2.
Perfect. Perfect. Looks like we can take another derivative. So we're going to do it again. Anand, do you want to give me the next derivative? I'm sorry. I messed you up. You're right. You could find an antiderivative absolutely on the same line. I want to just go do a couple more derivatives here. So can you give me the next derivative in this stack here? 6x, did you say? 6x
Let's see.
plus 8. Beautiful. So we're taking derivatives as we move down on the left. Beautiful. 6x plus 8. Lilia, you got me a derivative of 6x plus 8. 6. Perfect. And, Paul, what's the derivative of 6? Nothing. 0. So we're going to go down one more level. 0. Okay, so what you do in the ILATE table is you just start taking derivatives all the way down as far as you can go. Okay? It works really nice when you have this algebraic function. Ooh, not with ln, but with e's and tangents and sines. I shouldn't have put ln in there. You can erase ln. That's a goof on my part. Now, what we have to do is we have to pair it up with an antiderivative on the other side. So now what we're going to do is the v part. In other words, we're going to be taking the antiderivatives on the right side. Okay? So we have e to the minus x dx. I'm going to take the antiderivative. I want to know, what would v be? Who wants to guess for me? Patrick, you want to give me a guess on the antiderivative of e to the negative x? Negative e to the negative x? Absolutely. Plus c. Plus c. Nate, you want to give me the next one? Antiderivative of negative e to the negative x. It is 1000% e to the negative x. Yeah. And Megan, you got my next one? Antiderivative of e to the negative x is going to be negative e to the negative x. And Joel, you want to give me that guy? It is e to the negative x. Okay, so now I've gone all the way down. Are y'all with me? Yeah, go. Ask away, Joel.
For the C's though, do we...
Good question. Plus c's. Do we need them? Actually, we're going to ignore them. We're going to put plus c at the very end, at the back end. So yes, it is technically plus c. We're going to just tack that on at the very end with the antiderivative. But we don't have to take the antiderivative, thank you for asking, of c to the x each time. We're just going to put the big constant back at the back end. Okay, so I'm just going to erase that plus c, and we'll worry about that at the very end. Thank you for asking. Okay. Alrighty, so now we got our table set up. Now we're going to add some things in. Our formula is uv minus the integral of b du. So where is u and where is v? This is u and this is v, right? So it's uv. So what we're going to do is we're actually going to multiply these two together first. uv minus an integral. So now what you're going to do in this table is you're going to put a minus in front of all of this. And then we're going to multiply that times that. Then it's going to be a minus minus. So the next guy is going to be a plus in front of this. And that's going to get multiplied with that on the diagonal. And then it's a minus in front of that. And that's going to get multiplied with that. And when you get down to 0, 0 times anything is just 0. So when you get down to 0, you're done. There's nothing to worry about. So you don't have to worry about the 0 part. When you hit 0, you know you're done. But this is what we're going to do in our formula. uv minus the integral of v du. You're going to take this times this, minus this times this, plus this times this, minus this times this. It's a short way. What we've done is integration by parts, but we've done it stacking it on top of each other and made it nice and clean so that you can just do one big answer at the end. It's huge. It's crazy. You would get the same thing if you did integration by parts on top of integration by parts on top of integration by parts. But this answer here is going to be the following. X cubed plus 4x squared minus 2x plus 3 times negative e to the minus x. Oh, Tina, you're running out of space. Minus 3x squared plus 8x minus 2 times e to the negative x. Plus 6x plus 8 times negative e to the minus x. Minus 6 times e to the minus x plus c. There's my c at the back end. Do you guys remember? Oh, some of you might have done cross products where you do plus minus plus minus. I don't know if you remember, but that's what's happening here. Negative.
Why are we adding to 6x plus 8?
Excellent question. Because here's why. And I'm going to go right above, I'll show you, with the previous example. Do you see how in the previous example we did an integration by parts once, and then we did it again, right? And when we did it again, do you see how I highlighted that double pink? Because the minus, for the first part, minus du minus v du happens here, and then we did it again, so it happened here, and the minus minus created the plus. So that's what this is. This is the minus. This is the first minus integral. And then the minus minus gives us the next integral. And then the minus 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 gives us this integral. So what happens is we start positive and then it's alternating negative, positive, negative all the way down. Do you see what I'm saying? It's just that minus that's getting composed on top of each other applied. Does that make sense? Yeah, Munia, go ahead. Did I say it right, Munia?
Since you're multiplying it by negative e to the negative x, shouldn't it be negative?
It will be. So this guy will be a negative, this guy will be a negative, this guy will be a negative. It will turn out to be negative because it was e to the negative x. If it had been e to a positive, then it wouldn't have. Next question?
And could you simplify it by bringing out the e and then combining it?
Absolutely, you can. You could bring out front if you wanted to. If you were nice and clean and you said, oh, look, Tina, I want to take out e to the negative x, you could do that. And then you would be left with this, minus x cubed plus 4x squared minus 2x plus 3. And then it would be minus quantity 3x squared plus 8x minus 2 minus quantity 6x plus 8 minus 6, looks like to me, plus C. And then if you were really, really cool and loved algebra and mathematics, what would you do now? You'd combine like terms. Oh yeah. Well, we get minus x cubed, minus 7x squared, minus 12x, minus 9, minus 15, something like that. Other questions, Anna?
Is the reason we don't have an integral in this one because we went the whole way down to 0?
Absolutely.
Okay.
Absolutely. Because what happens is, technically, we do have an integral each time, but then we're taking the antiderivative as we go. We're catching that minus minus with this changing. And so, yes, that's exactly what happens. We got all the way down to 0. It's very specific. You can always use this method. You can always use the table method. It really comes in handy when you have some kind of long polynomial multiplied by an e, tangent, sine, cosine, something like that. Actually, e sine or cosine. I don't think we'll throw a tangent in there. I don't think your homework is that nasty. Okay, who else has questions? Questions. Yes.
Do you care on exams like whether we simplify it, like as far as like terms?
Nope, I don't care. You can do this or you can do this. You know, this is going to be fair to grade, so yeah, I won't care. I don't care. Yes. Either way. Who's got questions? All right. I was going to have you practice one, but because of time, maybe we'll practice one next time, okay? Or I'll practice one in recitation tomorrow. Do you guys see how the pattern works? Okay. I do want to give you, do you guys want to practice one or you think you're okay? Nobody, you guys are so polite and so quiet. Practice one, here you go. Ready? X squared plus 7x minus 1 times sine of x. X squared plus 7x minus 1 times sine of x. What is this sucker? It's a polynomial. What is it multiplied by? This transcendental function, sine. Big polynomial, sine. So sure, table might be nice. Set up a table. Absolutely. You're going to let u be your algebraic function, dv be the other part. Back, and then we're going to do a fun integral. We're going to combine sines and e's. Hello, beautiful integration. We are in our critical thinking stage right now of the mathematics, where we're like, okay, I just learned a method. Let me see if I can apply it. And let's see if I can remember those trig derivatives and antiderivatives, right? Negative. I put negatives in front. Oh, yes. Yes, yes, yes. We like the tableau method, the table method. Actually, a lot of the time students do. And we can even do it that way too, where you keep going over and over. Yes, how are you? Good? And you put minus in front when you multiplied down? Oh, yes, you did. Yes, you did. You good, Patrick? Questions? Nate, you good? Doing good? Paul, you okay? Lily, you good so far? Yep, everybody good? Bolden, how are you? Good so far? Okay, William's good? Everybody's good? Nate, you good? Other Nate? I got 2 Nates in here and I got 2 Kyles. 2 Nates, 2 Kyles. Nice, nice, nice. What clued us into the table was we had a polynomial and then we had a sign. That's what clued us into the table. So if we do u, dv, going down, x squared plus 7x plus, minus 1. Sine of x. Antiderivative is negative cosine x, negative sine of x, cosine of x. Making sure we have plus, minus, multiplying on the angles. Gives us, see if you guys are getting what I'm getting, x squared plus 7x minus 1 times negative cosine of x minus 2x plus 7 times negative sine of x plus 2 cosine of x plus c Did I goof it at all, guys? Or is that okay? Again, we could put the cosines together if we wanted to. Nah, not really. Is that right? Did I do okay? Did you guys get what I got? A negative? And then the negative would be a positive if you chose to put them together, and then positive 2x. Are we good? Everybody okay? Did you get it too when you did on top of this?
Yes.
Awesome. Awesome. Yeah. Questions? Questions? Okay, so that's about as challenging as it almost gets with integration by parts, okay? When do you know you use integration by parts? When you have products, okay? Products in an integral, that says integration by part tool, okay? Alrighty, question. Everybody's good? Any questions? Okay, all right. Don't worry, we're going to stretch our legs here in a minute here, but we're going to do this guy first. All righty. E to the 2x times the cosine of 3x. E to the 2x times the cosine of 3x. Biochems, chemistry majors, you guys deal a lot with e's. Well, e's occur naturally, don't they? I don't know if you guys have used them very much. Have you used the e's in the natural logs with exponential growths and things like that, or no? No, not yet. You don't use the ln's and e's? Not really. Oh, really? Oh, interesting. Because it comes up naturally in population models often where they have exponential functions. Maybe not. I know my actuarial science majors are going to use a lot of e's, okay, and ln's, because that's continuous compounding when you talk about continuous compounding with things. So exponential functions actually really come up a lot. Maybe my engineers do too. I think you guys probably do. But here we go. We've got an e to the 2x times the cosine of 3x. Notice it's very specific in that we have a product, but what we have is two transcendental functions. This creates an interesting dilemma. I'll tell you why. Because what's the derivative of E? Or the antiderivative of E is just always E again, right? So no matter what, you're constantly getting E's. What's the derivative of cosine is? Negative sine. What's the derivative of sine is? Cosine. What's the derivative of cosine? It's Do you see what's happening? We are getting a constant E's and sines and cosines getting multiplied together if we're going to do integration by parts. I don't know if this makes any sense to you. But part of the key of why integration by parts is so beautiful when you have an algebraic function is the ability to keep knocking down that algebraic function with the derivatives to make it smaller and make my integrals simpler. With the E's and the signs, are you kind of following my logic a little bit? I like to explain why we're doing what we're doing, and what we've got is a problem happening right here. You take the derivative of antiderivative of cosine or derivative of cosine, you're getting a sine mixed together with an E, and we're going to create a cycle. All right, but that's okay, because we're going to deal with it. All right, are you ready to do a really difficult problem? You ready? I don't give these on tests, but they are on your homework, okay? I usually don't unless I give it as extra credit. Sometimes I've given it as extra credit. It's a challenging sucker, okay? Not to say that you won't see it in differential equations. So let's talk about e to the 2x times the cosine of 3x. Here we go. This is an integration by parts. The reason it's an integration by parts is because we've got a product that's getting multiplied together here. What do you want to let u be? Well, I'll tell you what. Whatever you let u be the first time, you're going to have to stick with that the whole way down. For instance, if you let u be an e, then take the derivatives of e, then cosine better be an antiderivative and go sines and stuff. Whatever. Just be quiet, Tina. Here we go. I like to follow my I-late rule. It gives me an order and a process. So generally, trigonometric functions go before exponential functions. So I am going to use t, my trigonometric function, as my u value. Okay? So I am going to let u be cosine of 3x. And my derivative then, consequently, has to be negative 3 sine of 3x. My dv is going to be the rest. E to the 2x dx. And that makes v 1/2 e to the 2x. And we're going to apply this formula, ub minus the integral of v du. I'm not going to put it in the table because I'm going to tell you it's going to create for us this infinite cyclical pattern. I'm never going to be able to get a derivative down to 0, so I'm just going to stick with what I have here. And so what we have going on, and I'm going to actually do this and purposefully do this in your notes as well. I want to write down what I start with, which is e to the 2x cosine of 3x. And that is equal to uv 1/2 cosine 3x e to the 2x minus the integral of v du, which is going to be negative 3/2 e to the 2x sine of 3x. Somebody check my math and make sure. Ooh, Tina, you messed that up right there. That should be a dx on there. Let's see. Let's make sure we did that right. Okay, so I let u be my trig function, cosine 3x. The derivative of cosine is negative sine, but chain rule made me put the negative 3 in front. dv is e to the 2x dx. Antiderivative is 1/2 e to the 2x. So ub is going to be 1/2 cosine of 3x times e to the 2x. And I should probably move him in front, but okay, we'll do that right now. Do that right now. Minus the integral of v du. uv minus the integral of v du. Okay, we got another integration by parts. You guys see the next integration by parts? Again, right? Exponential times a trig function. So again, I am going to let u be my trig function. It doesn't matter where you put the negative 3/2. You can either put it with the sign or you can put it with the e. I don't care where you put it, but put it somewhere. Or you can put it out front, but then you have to remember to distribute it in. Do you like putting it out front and distributing it in? Were you doing that kind of on the last one, Quinn? Or maybe you didn't have, yeah. So you can either take him and put him on your sign, or you could take minus and put a plus right away too if you really be it, but we'll just do what we did to start, okay? All kinds of ways to do this. Are you guys finding me the derivative in the du and the v part? So now you're taking your derivative. This is going to give me minus 9/2 cosine of 3x. Derivative of sine is cosine. Times the derivative of 3x is 3. 3 times 3 is 9. Antiderivative is 1/2 e to the 2x. Okay, Tina. So, you got to make this a little smaller. Hopefully, you guys have a lot of space on your page to make a nice long integral right here. Minus this, which is uv minus the integral of v du. And I'll tell you what, if you don't like math, right now you're like, I don't even want to learn this, Tina. This is stupid. These are too many symbols. I don't like this. I know I can plug this into my tab. But I like math. I love algebra. I love putting things together. I love seeing how it all comes together with patterns. Oh my God, give me a pattern. We play with patterns, huh? All righty. Make sure I'm doing all my things right. Let's see. Minus 3/4 e to the 2x sine of x, uv, minus the integral of v du, negative 9/4 cosine 3x e to the 2x. If this gets you going, if this makes you super excited, then maybe you want to be a math minor or do lots with math, huh? But here we go. So what do we have going on? I'm going to clean it up just a hair, and let's make sure we get all those double negatives cleaned up because I really don't want to deal with double negatives here. I'm going to distribute. Minus is going to give me a plus. So I have 3/4 e to the 2x sine of x. I've got a minus. So that's going to give me minus an integral of 9/4 e to the 2x cosine of 3x dx. Make sure I got all those negatives right. Did I get that right? Negative went positive, and then I had a negative. Nope, not that first one. So I had a negative, which gave me a negative right here. So I think we did that right. So, here's our cycle. Here's our infinite loop. Here I have an integral with cosine and e. Here I have one with sine and e. Here I have one with cosine and e. You see my problem. So, we are going to be clever. We're mathematicians, all right? Mathematicians love patterns. They look for patterns. They look for putting together patterns. I'm going to do one more thing. You see this 9/4? I'm actually going to stick it in front. I'm going to actually put it in front of my integral. I'm going to take that sucker, erase. Oh my God, why can't I erase him? He doesn't want to let me put him in front. Nope. And I'm going to put 9/4 right here in front. Okay. You guys see a pattern? Do you see two places where we've got an integral of e to the 2x cosine of 3x dx? Do you see that pattern? Kyle, do you see two places? Where are they? Right here on the right side. Where else? At the top, or over here on the left side, right? So I'm gonna pink those suckers in, right? I've got this guy here. And I got this guy right here. Thank you. And what else is joining them?